Now, the oceans are not made of pure water. They have lots of things inside them. So what is actually inside the seawater? First of all, we have dissolved salts. That's why the oceans are salty. But we also have gases which are dissolved in the water, and that's why it's really important for climate and for climate change. We also have organic molecules in the oceans from organic matter. We also have suspended sediments, particles, sand brought in from rivers. So there's a lot of stuff which is in the seawater. But generally, we determine what's in the seawater by talking about salinity, which we use the letter S, which is basically related to how much salts we have in the concentration of the dissolved inorganic solids in the water. So it's not taking into the organic matter in the oceans. So salinity basically can be expressed as a percentage. What's the percent of salt we have in the oceans? So if we take, say, 100 kilograms of seawater, and it has 95 kilograms of water, 5 kilograms of dissolved salts, then the salinity is 5%. But generally, we use a unit called per mil, which is actually how many parts out of 1,000. Percentage is how many parts out of 100. So per mil is how many parts out of 1,000. It's written kind of similar to a percentage, but it has actually two little zeros at the bottom. So it's a slightly different sign when we talk about per mil. And here, if we have, say, 1,000 kilograms of seawater with 950 kilograms of pure water, 50 kilograms of dissolved salts, then we say that the salinity is 50 per mil. And 50 per mil is the same as saying is 5%. 5% of the water is salt. So generally, talking about salinity, we use per mil and not percentage, but you can convert from one to the other fairly easily. So if we look at the oceans, the average salinity of the ocean water is around about 35 per mil, which means 3.5%. 3.5% of the seawater is salt. So if we take a bucket of water and we evaporate it, 3.5% of that volume will be salt particles left at the bottom of the bucket. Brackish water or hyposaline water is normally when the salinity is below 33 per mil, and hypersaline, very salty, like the Dead Sea, is much larger and is defined as being larger than 38 per mil. Now, even river water has some salts in it from the natural rocks it's flowing over. So fresh water, sweet water in lakes and in rivers is around about 0.1 per mil or 0.01%. So it's not pure water that we have flowing in our rivers and in our lakes. There's a very small salinity, but nevertheless there are minerals and other things in the fresh water, in the lake and river water. And here you can see a comparison between basically the concentration in a freshwater stream, the amount of carbonates, calcium, silicate, and other components compared with what we see in seawater on the right-hand side. So, for example, carbonates, which make up a lot of the limestone and the rocks, when rivers flow over them, we actually have a lot of carbonate ions in fresh water, in stream water, but very little, just a trace of it in the ocean water. On the other hand, when we talk about salt, sodium chloride, NaCl, we see huge amounts in the seawater, but very little, although there still are some salts, very little in the fresh water in the streams. And when we add it all up, that's what we get at the bottom, the total salinity. When we look at all of these inorganic compounds, we get 34.8 per mil in the seawater and 0.1192 per mil in the freshwater streams. So how can we change the salinity in the oceans? There are a number of ways we could maybe increase the salinity or decrease the salinity. So if we first want to look at how we could decrease the salinity, so we need to add fresh water. So if we add fresh water to the oceans, then we're going to decrease the salinity. And how can we do that? Either by rainfall. So we know that rain is fresh water. Rain is kind of sweet water. If we have rainfall over the oceans, that's going to add fresh water to the top of the oceans and will reduce the salinity. When rivers bring water into the oceans, say for the Nile Delta, the Mississippi, they're bringing fresh water into the oceans, and that seawater will have a reduced salinity. Calving of glaciers, which is the actual physical, mechanical breaking off of icebergs off, say, glaciers and going into the oceans, which happens around Greenland, around Antarctica. The ice is actually fairly fresh water. When this breaks off from the glaciers and melts in the ocean, then this adds fresh water, decreasing the salinity. And the melting of sea ice over the North Pole in the summer months will also add sweet water to the oceans and reduce the salinity. On the other hand, the factors that will increase the salinity are mainly evaporation, like in the regions of the Hadley cell where we have the subsidence in the desert regions, not much rainfall, we have lots of evaporation, it's hot, and so as we evaporate the water off the oceans, the salt will remain in the oceans. When we evaporate water, the fresh water evaporates, but it leaves the salt behind, increasing the salinity of the oceans. And another way we can increase the salinity is by producing sea ice. When ice forms, it kind of kicks out, it removes the salt. It doesn't like the salt to go into the actual structure of the ice. So ice which forms, even when it's forming over the oceans, is made mainly out of sweet, fresh water, and then the oceans around it will keep the salt and will become saltier.